And we're now delighted to have a look at certification, something we've been talking about an awful lot. We're going to look at how to use simulation to get this done. Delighted to have James Pura from Hexagon and MSC Software. James, how are you?
Hi, Al. It's good to talk to you again. Thank you.
It's great to have you. You've got a few slides. Do you want to start and then I'll join in?
Yeah, I'd love to. Why don't I spend 10, 15 minutes just kind of talking about what we have to offer the eVTOL industry in terms of certification and why people keep coming to us for this, and then we could just have a chat at the end. How's that sound?
Great, let's do that.
All right, great. Sounds good. Well, thanks everybody that joined. I know that we're at the tail end of day one, and so thanks for everybody that has stuck with us all day long. Today we're going to cap it off with just a really a short little talk about certification of eVTOL aircraft. This is really the yet another major wave of transportation innovation that we're seeing, but this happens maybe once every decade or two. And I see this urban air mobility and sometimes electric urban air mobility innovation as really akin to when we switched from horses to horseless carriages, right? We didn't even call them automobiles at the time. We called them horseless carriages. And this picture actually came from the Uber Elevate conference in 2017, and I stole the picture from them. I hope they don't mind, but it was a great mindset to really set the stage for how we at Hexagon see this wave of transportation. Now, what's the problem that we're solving here? I know that this has been talked about a lot with a lot of different speakers over the time, but over the day. But really, what we're talking about is doesn't matter what language you speak or what country you live in. Traffic is terrible in the major cities, and not only that, but the world needs cleaner air. So if we get out of the cars and onto UAVs or UAMs going from one side of the city to the other, then we might have something going on here. And why is it the solution? Why is it not just an industry trend or some sort of gimmick or something like that? Why is this here to stay? What we're really talking about is a accumulation of a bunch of different technologies that are really hitting home for a lot of the public here. Sure, you can get from point A to point B quicker, but you're also talking about bettering the planet in terms of less CO2 emissions, improved mobility. You're going over the traffic, which is just wonderful. Greater safety, less cost. All of these things can kind of all accumulate in the eVTOL industry. So the example that I like to talk about is especially when we're talking with our industry customers in the aerospace industry, is something that hits close to home every single time I go to San Francisco or San Jose. There is always a customer on the complete opposite side of the bay that I need to go visit, and the only two ways that I have right now are either I rent a car or I hop in the back of an Uber or I take a train, right? There's three really options, and all three of those options really take at least an hour and a half to 2 hours to go there. God forbid there's a car crash or something like that, right? And it's really something that the VTOL industry I wish was here immediately, because I would use it right off the bat. Now, urban air mobility for civilian use case is only one of 4 major use cases that we're seeing worldwide amongst our customer base at Hexagon here. Sure, we're talking about air taxis, but we're also talking about things like cargo drones, personal AVs, and then also the military aspect, which the military has always played a role in tackling the cutting edge technology and really proving out the concept, and then the commercial industry kind of comes in a little bit later. And so we're seeing a lot of this happening on all 4 prongs of this, and they're all in need of engineering simulation. So we see, just if we were to just look at the commercial air taxi side, a lot of our existing customers that we're very proud to call our customers are in this space and are some of the leaders in this space. And we can see, the thing I like, this is kind of an eye chart, so don't really focus on the numbers here, but really focus on those pictures on the left-hand side. That's my favorite. is because a lot of these companies are starting with completely clean sheet designs. They're brand new fly-by-wire systems, never been tested before. You know, tilt rotor aircraft, who knows how many rotors are on an aircraft. You know, the Lilium has like, what, 20, 30, 40 different motors on that and blades on that vehicle. It's just really cool to see completely different clean sheet designs. Whereas if you look at a commercial jet airliner these days, it doesn't matter what company, Embraer, Boeing, Airbus, they all kind of look the same, just different sizes, right? So we are really in that cutting edge time of the industry here, where no design is a bad one right now, right? And we're seeing this all over the world. It's not just in English-speaking countries, not just in rich cities. It's all over the world. We're seeing, at least from MSC Software or Hexagon's side, we're seeing lots of companies just springing up in areas that again have difficult traffic situations, difficult infrastructure, and need for cleaner air and quicker transportation options. So what are the challenges? Let's say you are either a startup, or maybe you're an OEM, maybe even somewhere in the middle. Maybe you're a small to medium business, and you are seeing the challenges of developing and certifying a new vehicle. What are those, right? Well, the challenges for eVTOL can be three different ways, three different prongs that we can help with. Sure, what we're known for is really the engineering technical aspect. Things like proving safety and certification, reliability, lightweighting, structural, making sure it's quieter, making sure the controls and mechanisms, all that stuff. But engineering is increasingly being used on the commercial side as well as the regulatory side as well. And all three of these are needed. It's an intricate dance between all three of these that are really needed in order to, like your previous speaker said, really to convince the public that this is safe and this is reliable, and nobody's going to die on these things. So from the technical side, what are we looking at here? From the technical side, us at Hexagon and MSC Software, we're really known for this left-hand column, right? This is our oldest business line. MSC Nastran, we helped develop it back in the 60s when we were sending astronauts to the moon. But we have been in so many more facets of the technical engineering realm now, where, and pretty much every single one of these is needed by a new eVTOL team before they certify their vehicle and before they prove to the EASA or the FAA that they actually have a safe vehicle that the public can fly on. So I like this slide because it talks about all of the technical challenges that engineers around the world, no matter what language they're speaking, if they're in the eVTOL industry, there's a really good chance that they're running into at least 2 or 3 of these issues right now, and it's keeping them up at night. And this is just a slide to show that even at Hexagon, even though we're software providers and simulation tool providers, we are keeping a keen eye on all the latest and greatest certification standards that are coming out for this industry, because as soon as they come out, our partners in this industry come straight to us and they say, okay, how do we solve this challenge? And we definitely help them out with that. So now that we understand the pain points from the engineering side of the house, what are the solutions? Right? What's that product that you're hawking, James? Well, it's not just product; it's an industry partnership. Okay, so we are more than just a software vendor. We are an engineering extension to your team. So we have been involved in a lot of aircraft firsts over the past 50 years, and this is just yet another aircraft first that we are very proud to be a part of. So things like commercial jet aircraft, the first time that airplanes went from commercial propellers to commercial jets, everybody was kind of scratching their heads going, okay, how do we do this? Well, before we build an entire airplane and then crash it, let's simulate it using engineering first to make sure that we have a good design. And then once we hit the manufacturing floor, that we have a higher chance of success, right? The first heavy lift twin rotor helicopter, is this thing even going to fly because it has to carry so much cargo? Well, I don't know. Simulate it. Let's find out. And then over on the right, the first time we actually tilt rotor on the V-22, right? How are we even going to tilt a rotor when we have so much cargo sitting in the bay of that thing? Is this thing just going to fall out of the sky? Well, I don't know. Let's simulate it and let's make sure that it works before we go to the manufacturing floor. And the biggest takeaway from here is this bottom sentence here. All of these 3 designs were designed to not just be demonstrators, they were designed to be workhorses, right? They're not show ponies, they're workhorses with a lifespan of decades. Every single part of all three of these vehicles is designed to fail at a certain point. So, and then they have been designed so that, and analyzed so that when it fails, we catch it before it fails and then replace it on the part so that these aircraft last 20, 30 years. Okay. And the same thing can be said for eVTOL industry. This is nothing new. Sure, these designs look new. Sure, the engineering concepts, like multiple rotors and tilt versus fixed rotor, all this kind of stuff. Sure, these are novel designs and new aircraft, but the engineering fundamentals have not changed. And at the end of the day, if you want to find a crack when it's millimeters wide and you want to simulate it so that you know exactly where that crack is going to show up so that you can replace the part first, come to us. We got your back. Okay. Now, we are more than just structural simulation. I mentioned before, like if you want to do a full computational fluid dynamics analysis and you want to figure out whether fixed rotor or tilt rotor is good for you and you want to simulate both just as a design trade-off study, cool. We got you covered. If you want to see how loud your propellers are actually going to be and your rotors are going to cause whether your passengers are going to need headsets or whether they can just walk in and talk on their cell phone inside of the cabin, we've got a full suite of acoustic solutions for you, right? If you want to see what it's like to manufacture something out of composite versus aluminum, we got your back on that too. Anything involving structural simulation, again, this is our oldest and best technology. We've got your back for that, okay? Now, in terms of the main three needs that everybody that's building a vehicle, whether you're Boeing, Airbus, Bell, or whether you're a small startup, you're dealing with things like powertrain, structural, and whole vehicle analysis. And all three of these are changing with every new design. And you need to be iterative and you need to be quick. And we know what you need and we got your back. So again, this is just a kind of a deeper dive into the powertrain aspect. We've got a lot of different software solutions that talk about, you get a lot of heating, moving parts that cause friction, all that stuff. We can design around that. The aircraft simulation from concept all the way to end of life, we can simulate that and make sure that you know exactly what's going to happen 20, 30 years down the road, and everywhere in between, what happens to your aircraft airframe. Now, in terms of reliability, right? Things like durability cycles and fatigue life cycles, we got your back on that. We can tell you which part on your aircraft is likely to fail first or second or third or fourth so that, again, you know whether that's going to be, you can design a maintenance schedule around it, right? And this is what our major decade-long customers are using our solutions for today. And we want to make sure that, that eVTOL solution providers today that are building these new aircraft know that we're around to help you guys out with that. Lightweighting, right? For every ounce that you take out of the airframe is another ounce that you can add to your passenger quota, right? And that's important because passengers are equal money in terms of the commercial aspect of this. And we want to make sure that you have the lightest and yet strongest airframe that you can possibly have. And we've got a lot of structural design and lightweighting solutions for you. Acoustics, I mentioned before, the two biggest sources of noise here are your rotors and causing noise, as well as the noise inside the cabin, right? You've got your noise from external, and you want to make sure that things like encroachment or things like local aircraft or airport ordinances are followed. But then also you want to make sure that that someone can hop on one of these eVTOL aircraft and make sure that they can still hear themselves think, right? It's not so loud that they might not have to wear a headset or something like that. We can cover both aspects, both external and interior. Things like tilt rotors and wing flaps, these are things that we've been doing for decades. We got you covered in terms of that. And here's some animations of things that you can do using our software solutions. Now, a lot of this seems very sophisticated, but and then your brain might be going to where, well, is it going to be too expensive? And the answer is no. So you don't have to be a Boeing or an Airbus in order to afford our software solutions. Okay, We got you covered when it comes to that. We've got nice, good pricing situations where you can kind of grow along with the your company and make sure that you're not betting the farm just on software engineering tools as some of the other software providers have done here. Okay, and then really your main takeaway here is that you're coming to an engineering simulation house of Hexagon that all of these household names have relied on us for decades. Okay, so you're designing something new. You don't really know what the industry standard is or what the best-in-class offering is. Come to us. We can help you out. But we also have the ability to customize our solutions directly to your aircraft. You want to leverage maybe some scripting in order to automate some stuff and maybe do some really cool artificial intelligence or Python API type stuff. We got your back. And we've done it before, and we'll do it again. And we would be happy to help this industry do the exact same thing. Okay. So there you go, Al.
James, that was really cool. I particularly like the fact you did the 707. That's remarkable. I've got a question actually from Robin Barton-Jones, who says, when you say you'll act with small companies, would you be able to come to a solution for one or two simulation engineers?
Absolutely, good question. So we have situations where startups come to us and they say, look, we need to certify this aircraft, and we have one product line, and we need to go to market with this one product line. So we need to be as cost conscious as possible until we get to that stage. Can you help us out? And so, yes, absolutely, we do. We don't charge you the same prices as if you have 20 or 30 engineers, as opposed to if you only have one or two engineers, because obviously you don't need the same engineering capability, right? But if you're a Boeing or an Embraer or an Airbus or something, and you have teams of engineers at multiple different locations around the world and across the country, obviously you need a different solution than if you're a startup and you're working maybe with one or two engineers. So definitely contact us, and we'd love to talk to you about that. You're going to be pleasantly surprised with our solutions for you.
And the other issue which come up all throughout today is noise. For community acceptance.
Yeah.
And anyone who's been in a helicopter, I'm guessing you've been a lot because you've got some pretty cool helicopter clients. Are we going to be able to get to talk to us about noise?
It's a question that I don't think anybody has really answered yet, because we don't really know, right? The question is like, so if you hop in a helicopter today, the rotors are so big and the cabin is so loud that everybody needs to wear a headset in order to even hear yourself think, right? So the question is whether you can actually get the rotor so small that you can hop in and the passengers don't have to wear headsets. Question mark. Not sure if anybody has actually solved that problem yet, but you can simulate it. You can definitely insert clean sheet acoustic models, and we will tell you exactly what that decibel level is going to be. Now, the other thing to worry about, and this is me personally, is if I'm walking down the street in New York City and these things are flying overhead, is it going to be so annoying to have these things flying overhead that I can't actually have a conversation with someone walking down the street? That's another issue that we can simulate, and we can tackle that. Now, it's a completely different engineering tool set, and well, it's the same software tool set, but it's a completely different engineering problem that you would need to solve. And so we've got lots of customers around the world trying to tackle this challenge. Some of the smartest people in the world trying to tackle this. We'll see whether someone comes up with the answer.
You've got some nice comments here. Robin Bransell saying, James, I like your view that design is for workhorses and not show ponies. And Bill Johnson's asking, have you embraced a digital twin mindset?
Digital twin is yes and no. So it depends on who it is and what your definition of digital twin is, right? So that buzzword means different things to different people. But at the end of the day, yes, right? I'm not going to give you some lawyer speak and say yes and no and maybe or this and that and the other thing. At the end of the day, you've got something that you're going to manufacture, and you want the exact same digital copy of it so that you can simulate it and know exactly what it's happening. And in a way that has been happening, not real time, but that has been happening for like the last couple of decades, right? The reason why a 737 is so safe, or an Airbus A320 right now is so safe, is because every single part of that aircraft has been simulated. And we want to do the exact same thing for eVTOL. So as deep as you want to go, yes, we can do digital twin, and we can copy as manufactured and not just as designed.
And I guess that the final question is, we've spent most of today, or not most of today, but I think at these conferences we always get very focused on certification and getting the aircraft allowed to fly. What about simulation, manufacturing, and 3D printing and things like that?
Simulating as manufactured and simulating as 3D printed manufacturing is an incredibly important and critical piece to all of this, right? Because you can design the utmost perfect design, and if you don't go out to the machine shop and have it exactly made as just per specification, you're hosed, right? It's not going to work. And maybe it's out of spec, maybe it's not, it's made out of the wrong material, maybe even if it's made out of the right material, but it's made incorrectly as the step-by-step. And so manufacturing simulation is incredibly important. Now, I kind of glossed over that here, but we've got an entire suite of software that focuses specifically on as manufactured. And you took 3D printing out. And 3D printing is a great example, right? If you 3D print something that is long and skinny, well, you have to start printing down here. And by the time you're printing up here, it's molten metal. Let's say you're 3D printing out of metal. That's the assumption that I made. It's molten metal that's really hot up here, but by the time you get down here, it's already cooled off. And so what does that mean in terms of thermal characteristics? It probably means by the time the whole part cools off, your part is no longer like this. It's probably bent like this, right? Because thermal deformation. And that part's not going to work. So you can actually simulate it now. It's kind of voodoo science, because that's not the part of the company that I'm a part of, but you can actually 3D simulate it so that you can 3D print it this way, so that as thermal deformation happens, it happens perfectly in specification, and you're first time right. It's really kind of cool. I've seen it happen in front of my eyes, and I still don't believe it. So it's pretty cool.
That's awesome. James, thanks so much. It's really mind-blowing what you can do, but thank you. We really appreciate it.
Thanks a bunch. At the end of the day, we want to help this industry succeed. So contact me. We'd love to help.
Great. And we look forward to seeing the logos on your slide next year for all the new ones. Thanks very much, James.
See you later.